Hi everyone, welcome to the fifth video of system design series. In this video, we will talk about availability patterns. In the last video, we covered CAP theorem, where we talked about consistency, availability, and partition tolerance. And in that video itself, we covered consistency patterns. That is nothing but the type of consistencies. That is eventual, weak, and a strong consistency. But in this video, we specifically will cover availability patterns. So in our modern time, we are relying on services and devices a lot, and we expect them to be available all the time. Examples: phones, ATMs, credit card verification systems, and payment systems. So we are highly dependent on them, and we want them to be up all the times. And embedded designers are asked to create systems that are running 99.999% of time. This is also termed as 5-9 availability, and this actually is equivalent to less than 1 second of downtime per day. And this is what makes a highly available system. So these highly available systems are a combination of redundant hardware and software to manage fault detection and correction, so without human intervention. So let us understand what patterns do these systems follow. So we got to know from our previous video that fault or failure can happen at any time. Our application should be able to withstand it. Now, if we want our application to have high availability, there are basically two ways in which this can be done. First is redundancy, and second is failover. Now we'll talk about each of them in a little more detail. Let's start with redundancy. So it simply is a practice of duplicating critical components in a system to avoid single point of failure. So what we do, whatever important piece of code or important data that we have, instead of keeping it on one single server, we replicate the data as it is and keep it on multiple servers. So in case of any failure with one of the systems, we have another system which can come into action and handle user request. So that makes our application available, because we don't know when a failure might happen, right? And redundancy also are of three types. First is hardware, software, and geographic. So hardware, as the name says, we duplicate hardware components, and these hardware components can be processors, memory, power supplies, or storage devices to provide fault tolerance and also increase system reliability. So these hardware components, they work in parallel, and they are designed in such a way that they can take over in case of failure in the main, in case of any failure in the primary or the main hardware. So yeah, so that's for that reason you can consider them as a kind of backup also, or they can be running at the same time also. So this was all about hardware redundancy. We also have software redundancy. So you might think, why software? So there are possibility, there are chances of software crashes also, right? Let's say we have our application running, some kind of input was given by the user that our application was not able to handle at that time, and it crashed. Now, if that happens, though our server are running, but fault happened inside the server, and that is in the software. So to prevent that and to keep our service running, we should provide software redundancy also. So in this case, we replicate the software in multiple servers. So our software, instead of running at one place, runs at multiple places. So if one server is not able to handle because of software crash, other servers will still be able to process the request. And third is geographic redundancy. So in case what happens, the servers are placed at different geographic location. So let's say for some reason there is a power cut in India's server. Let's take an example. We have two servers placed in India and Japan. Now, for some reason, there is a power cut or power failure in India's server, and that has been there for a long time. Let's assume. Now, server farm is not able to run just on generators, so that will go down. So what we do, we replicate the complete farm in Japan also, and whatever user requests are coming will be diverted to the Japan location, and the user can still and the system will still be available. There might be some delay, but our system or our service is available and it has not crashed. That is a good thing. So this is just a diagram representing geographic redundancy. So we have two similar setups placed at a different location. And second type of availability pattern is called failover. Failover simply is the process of switching to a backup system or component when the primary system fails. Now, consider this diagram. We have a primary server and a secondary server. Now, by default, primary server is always into action. It is processing user demands, user data, whatever requests are coming from the user. But for some reason, it goes down. Now we also have a secondary server. So this now all the user requests coming here will be diverted to the secondary server, and whatever data is stored by the primary server is also replicated always, like simultaneously replicated to the secondary server. So like whenever secondary server has to come into action, it knows about what like it has the latest data available with it. So this failover can be of two types. First is active passive, and second is active active. So in case of active passive, there is a standby system that takes over when the primary system fails. So we can compare this to the example of generator. Whenever there is a power supply coming, our generator is there sitting in the standby but not running. And as soon as there is a power cut, our generator usually waits for 10 seconds and then comes into action and then continues the electricity supply. So this is somewhat similar to that. Whenever the main server goes down, the backup server comes into action and makes our service available again. Now, how does the backup server comes to know there is a breakdown in the primary server? So heartbeats are sent between the active and passive server. So heartbeat, you can consider heartbeat as a ping request. So there is continuously ping request being sent by the passive server, and whenever there is no response from the active server, passive server gets to know that okay, something is wrong, I need to come into action. So what it does, it takes over the active server's IP address and resumes the services. Now, how long will this gap be? Like how long will be the downtime? So that is determined on how the standby server was kept. So there are two possibilities. First was hot standby, second was cold. So hot you can consider basically a sleep mode. So the standby server was sleeping, and whenever it got to know that it has to come into service, it gets active very quickly. But cold standby means the server first has to start itself and then start processing the request. So in case of cold standby, the downtime can be a little longer. So active passive failover can also be referred to as master slave failover. Second type, we have active active. So in case of active active failover, there are multiple systems that share the workload, and if one system fails, the other take over its function. So it's pretty simple. So something what we covered in our load balancer video. So we have multiple servers in place, and all the servers are processing one or the other request of the server. And this can also be referred to as master failover. So what are the disadvantages of failovers? So failover adds more hardware and additional complexity. So if you see in this case, we need to keep a backup server that is not actively running. It's not processing any demand, but we still have to supply power to it and purchase the hardware because we might need it at some time in future in case of any failure. And second is there is a potential for loss of data if the active system fails. So let's say the active server was saving some data into the system, and while saving the data, there is a breakdown. So we know that data is simultaneously copied to the backup server also, but we might not know that whether it is happening at every microsecond, right? So in that case, whatever very recent data was written in the active server might not be available with the backup server. So in that case, there is a potential loss of data. So one good example of availability patterns can be cloud computing. So cloud computing is basically an ideal environment for implementing it. They offer redundancy, failover, load balancing services that can easily be integrated with our services. So, and they provide additional functionalities also, such as scalability, elasticity, and cost effectiveness. So we don't need to build our own data centers. We can simply occupy the services being provided by cloud computing, and we can get additional services also at reasonable prices. So this was all in this video. I hope you learned something new. Thank you for watching.